Okay, question 6 from this assignment was exceptionally simple. We have part 1, a sine wave is offset 1/10 of a cycle. Okay, so 1/10 of a cycle with respect to time equals 0. What is the phase in radians? And then what is the offset of a cosine wave with respect to a sine wave? And we know that's 90 degrees. Why do we know that's 90 degrees? I guess the easy way to think about it is what is a sine and what is a cosine. I do have a ruler. And I will get a highlighter as well. So, okay, what is a sine? So I'm going to draw a right angle triangle. My idea for this particular drawing is courtesy of this old Tony, the YouTuber, who is explaining something called a sine block for machinists. So let's take a look at this triangle. Okay, this is an ugly triangle. I'm going to restart. It's a much nicer, smaller triangle. Okay. Call this angle theta. This is a 90 degree. Okay, so if I take a light source and I shine the light source from, let's say, so let's first look at the sine. So let's say I take a light source and I shine light from over here. Okay, so that beam of light will hit the hypotenuse of this triangle, and what it will do, essentially, is it will draw the shadow that this hypotenuse casts over here. So, if I were to extend these lines a little bit, and if I wanted to draw that shadow, essentially it would be this point to that point, and then, right, because the light is only going in this direction, so this point to that point, that height difference would give me my, well, it would give me my sine. So this side length here, this length, is the sine length, right? So this little guy here, if I draw this out, right, with another horizontal, so I extend this line and I keep that horizontal, so this again is theta. But this height from here to here is the length of the sine. So this is our sine. In other words, it's the projection onto the vertical in this case, right? If I took this angle here, it would be the projection onto the horizontal. But either way, it's the projection of the hypotenuse onto the opposing, right? Onto the opposing side length. So it is the perpendicular of the projection. Let's put it that way. The cosine is the parallel of the projection, so it's this length here. Will give me the cosine. So the ratio of this length to that length, I should say rather, gives me the cosine, and the ratio of this length to this length gives me the sine. So this projection is the sine, that projection is the cosine. So if we think fundamentally, right, it has a right angle triangle, ergo the sine and the cosine must be out of phase by 90 degrees. Why? Because they're perpendicular to each other. So that's an easy way to understand why the sine is always going to be 90 degrees out of phase with respect to a cosine and vice versa. So I guess that's the simply put. Now if I think about a sine wave being offset by 1/10 of a cycle. So I look at the equation of a sine wave, right? So I would say some function of x is equal to some amplitude sine, I guess this here would be the angular velocity, right? The free, well, it would be omega. I'm used to seeing this as omega, right? The angular velocity plus the sine, plus the offset, right? Plus the phase delay, which we'll call by another angle phi. Okay. So if you think about it, this will change how fast, like this whole entire quantity here becomes the frequency, and this becomes how far I've slid it out of the zero, right? So sine wave, I have to just use my straight edge. Sine wave will always start at 0, right, at the 0, 0, and then it will go up and come down, and this will always happen at pi, right? Because one cycle is pi over, or is 2 pi, right? So over here we would have pi over 2, and there's a lot of special angles in between that we don't really need to think about right now. But if you think about just this here shifts this position, right? It either starts it earlier or it pushes it later. If I push this later, let's say I start taking this and I push it all the way 180 degrees, right? Let's say I look 180 degrees. So I go back, even farther. Okay, so if I go back even farther, 180 degrees, or rather, yeah, 180 degrees, I have 1 over my sine wave. If I go back 2 pi, I have a sine wave again, so we can see it oscillate in that way. So fundamentally put, understanding that this is the equation for a sine wave, which is, I think, like a first-year calculus type style problem, helps understand what this offset is doing and helps us understand the relationship between the sine and the cosine. Right? I mean, an additional thing is if I were to shift this 90 degrees and start here instead, you can see that I'm starting exactly at a cosine, right? So either I can look at it from a right angle triangle perspective, or I can look at it from the sine wave. I think fundamentally this is why it's out of phase by 90 degrees, and this is just a plot of that being out of phase. So I think the better option to understand why it's 90 degrees out of phase is to think about it, what it is by definition. So now let's take a look at what is this phase in degrees and radians. Okay. A sine wave is offset by 1/10 of a cycle with respect to time 0. So, okay, in this case we have a function of time is equal to a sine omega t plus phi. Okay. Offset by 1/10 of a cycle. So a cycle is 2 pi radians, right? 1/10 of a cycle is 2 pi over 10, which is 1 pi, right, over 5. Okay, so that's pi over 5 if I want that in degrees. Let's see, there are 180 degrees per pi radians, so I have 1/85. So there's the answer to that. Now, what is the offset of a sine with respect to a cosine? We already looked at that. So, pretty simple problem, not a big deal, as long as you recall your geometry. So I'll see you in the next video, and we'll do next question. Okay.